If you bought a mid-range washing machine in 1990, you likely paid around $350. For context, when adjusted for inflation, that equates to roughly $850 today. It was a significant household investment. But in exchange for that capital, you received a machine engineered with heavy-gauge steel, copper wound motors, and mechanical switches. It was a machine that easily lasted 15, sometimes 20 years. Today, you can walk into almost any major retail store and purchase a brand new washing machine for under $400. On paper, this looks like a triumph of modern globalization. We have seemingly unlocked a world of unprecedented consumer abundance. But in reality, that $400 machine is a ticking clock. It is highly likely to suffer a catastrophic component failure within 5 to 7 years, often costing more to repair than to replace. Today, we are surrounded by things that feel cheaper, look sleeker, and break faster. It is easy to look at this phenomenon and point to corporate greed, to assume that boardrooms of executives are actively conspiring to sell us garbage. But the reality is far more systemic, far more calculating, and entirely driven by the cold, hard mathematics of survival. This is not just planned obsolescence. This is what industrial economists call survival degradation, the inevitable structural decay of the physical world, driven by a global race to the bottom. To understand how we arrived at this point, we have to decouple our understanding of value from the price tag. For decades, the dominant narrative surrounding product failure was planned obsolescence. This is the deliberate engineering of a limited useful life into a product, forcing consumers to buy the newer version. The classic historical precedent is the Phoebus cartel of the 1920s, where the world's leading light bulb manufacturers secretly agreed to restrict the lifespan of incandescent bulbs to 1,000 hours, down from their true potential of 2,500 hours. It was a cartel designed to artificially stimulate demand. But today, the forces driving product decay are fundamentally different. Manufacturers are not designing products to fail because they want you to buy another one next year. They are designing them to the absolute limit of structural tolerance, because if they did not, they would simply cease to exist. At its core, this is a crisis of margin erosion. Over the past 30 years, the cost of raw materials has climbed steadily. Steel, copper, aluminum, and petroleum-based plastics have all experienced significant, long-term price appreciation. Meanwhile, the cost of global energy, labor, and compliance has steadily marched upward. Normally, when input costs rise, the retail price of a finished good must rise alongside them. But here is the catch. Modern consumer psychology does not work that way. Through a phenomenon known as price anchoring, consumers have become psychologically locked into specific price points. Because big box retailers have spent decades conditioning us to expect a flat-screen television for $300 or a microwave for $80, those price points have become concrete. If a manufacturer attempts to raise the price of a standard microwave to $180 to preserve its build quality, the consumer does not see a better engineered product. They simply buy the $90 competitor next to it. Consequently, manufacturers are caught in a structural vice. They cannot raise their retail prices without losing massive market share, yet their cost of production continues to climb. To survive, they must engineer the cost out of a machine. Let us look at the anatomy of a modern home appliance to see exactly how this mathematical trade-off manifests. Consider the washing machine again. In 1990, the internal drum of a washing machine was typically supported by a cast iron spider bracket, pivoting on heavy brass or copper bushings. These materials are incredibly durable, resistant to chemical corrosion from detergents, and capable of absorbing the violent kinetic energy of a high-speed spin cycle. But copper and cast iron are expensive. If you open up a modern $400 washing machine today, you will find that the cast iron bracket has been replaced with a cast aluminum alloy. Aluminum is lighter, cheaper, and far easier to manufacture at high speeds. However, aluminum is also highly susceptible to galvanic corrosion when exposed to water and alkaline laundry detergents. Over time, the metal structurally decays, eventually cracking under load. Meanwhile, those heavy brass bushings have been swapped out for injection-molded POM plastic. Physically, the margin of safety has been entirely stripped away. In engineering terms, this is known as finite element analysis, or FEA. In the mid-20th century, engineers did not have access to supercomputers that could simulate structural stress. To ensure a product did not break, they simply over-engineered it. If a component needed to withstand 10 pounds of force, they designed it to withstand 50. Today, FEA software allows a manufacturer to calculate the exact structural limits of a plastic gear down to the micrometer. If the gear needs to withstand 10 pounds of pressure, the software helps engineer it to withstand 10.1 pounds and not a single ounce more. Every excess molecule of plastic is viewed as waste. If you shave off just 2 cents of plastic from a single gear, it may seem insignificant, but when you are manufacturing 10 million units per year, that minor adjustments yields $200,000 in direct savings. Multiply that optimization across all 500 components inside a washing machine, and you have saved millions. But the systemic consequence of this extreme optimization is a product with zero tolerance for anomaly. If the user slightly overloads the washing machine, or if the water temperature runs slightly too hot, the plastic gears and aluminum brackets are pushed past their hyper-optimized limits. The system cascades into failure. This vulnerability is compounded by the globalized nature of modern supply chains. To keep production costs at an absolute minimum, brands no longer manufacture their own components. Instead, they rely on a vast layered network of third-party suppliers, primarily concentrated in East Asia. A single household appliance may contain parts sourced from dozens of different factories across multiple countries. This hyperfragmentation introduces a massive quality control challenge. If a supplier in a secondary province decides to substitute a slightly cheaper chemical compound into their plastic injection molding process to preserve their own razor-thin margins, the brand itself may not realize it until hundreds of thousands of units are already sitting in retail warehouses. And once a component fails, the modern consumer encounters the final structural barrier to durability, the death of repairability. In 1990, if a washing machine broke, you could call a local technician who would arrive with a toolbox, diagnose the mechanical failure, and swap out the broken part for a nominal fee. The machine was modular. It was designed to be disassembled with standard tools. Today, that is virtually impossible. To save assembly costs on the factory floor, modern products are no longer held together with screws and bolts. Instead, they are snapped together with heat stake rivets, ultrasonic welds, and structural adhesives. To access a single broken 10-cent plastic gear, the technician must literally break open a sealed outer casing. Furthermore, mechanical components have been systematically replaced by digital control boards. Even the simplest modern toaster or refrigerator now features a microchip to manage heating cycles or operate digital displays. While these chips make appliances slightly more energy efficient, they introduce a single point of failure that is entirely unserviceable by the average consumer. If a single capacitor on a proprietary circuit board pops, the entire appliance becomes an expensive paperweight. The replacement board often costs more than a brand new unit, while the labor required to install it makes professional repair economically irrational. Ergo, we throw the entire machine away. This is the hidden tax of modern consumerism. We believe we are saving money by purchasing cheap, highly accessible goods. But when we look at the life cycle cost of these products, adjusting for how frequently they must be replaced, we realize we are actually paying a premium. We have transitioned from an economy of ownership to an economy of structural renting. You do not truly own your appliances anymore. You are simply paying a recurring subscription fee to keep functional machinery in your home. The systemic implications of this shift stretch far beyond your kitchen or laundry room. It drives a massive continuous influx of e-waste and physical refuse into landfills, accelerates the depletion of critical mineral resources, and locks global manufacturing into a perpetual loop of low-margin, high-velocity output. It is a cycle that cannot easily be broken because the incentives of the entire global retail ecosystem are aligned to keep it spinning. Retailers want high turnover. Manufacturers want low production costs. Consumers want low prices. In this triple bind, quality is the only variable left that can be sacrificed. So the next time you purchase a product that feels suspiciously cheap, or find yourself throwing away an appliance that is barely 2 years old, remember that this is not an accident. It is not a flaw in the system. It is the system operating exactly as it was designed, a quiet, mathematical surrender of durability in the name of survival.